I'm Miss Paws, and welcome to the Era of Agents, a video series designed for professionals navigating the fast-changing world of AI. Whether you're brand new to AI, brushing up on the basics, or someone who knows the classical AI models but is feeling left behind by the hype, this series is designed to guide you through the essentials. No fluff, no gatekeeping, just clear practical guidance on how modern-day AI can support your work streams, complete with real-world examples and coding samples. So let's get started. These past few years, we have seen some of the biggest advances in AI with generative AI. LLMs, or large language models, have demonstrated remarkable capabilities, from generating realistic text and writing functional code to creating images and videos and summarizing complex documents with impressive accuracy. Naturally, industry leaders saw the potential. AI that could generate text, code, and summaries meant faster workflows and greater efficiency. So now we're entering a new phase, a shift toward agentic AI, where these systems, or agents, can independently make decisions without step-by-step human instructions. Naturally, with this wave of disruptive technology, we have seen an explosion of new Python libraries, frameworks, and orchestration systems, each designed to help developers harness the power of modern AI. We'll start from the ground up, beginning with the basics of modern AI, and gradually build toward multi-agent agentic systems in later videos. Today, we're going to create our own AI model endpoint on Azure Foundry. First, let's navigate to Azure Portal. We're going to create an AI Foundry resource. Enter your subscription. Create a new resource group. Enter the name for your Foundry. Select a region nearest to you. And enter a default project name. And we're going to use all the default options, so just keep on pressing next. While our Foundry instance is deploying, let's talk a little bit about what we're doing and why we're doing it. Azure Foundry is a unified Azure service for enterprise AI development. While there are many cool features on Foundry, we're mainly going to use it for creating a model endpoint. In other words, we'll set up an API endpoint that lets us call a large language model, LLM, directly from our applications. Now, we can definitely create a model endpoint on, say, OpenAI. One reason we use Foundry, though, is that Foundry gives us access to multiple models, not just from OpenAI, but also from Meta, NVIDIA, etc. The other, and arguably more important reason, is that Foundry delivers enterprise-grade security and data privacy. You see, Foundry is hosting these AI models on Microsoft servers instead of, say, OpenAI servers. That means any model prompts or outputs are treated as customer content and will not be shared with or exposed to OpenAI. So yes, we're fully comfortable working with proprietary data using these models. As part of security and compliance, Foundry also has features to help detect and prevent harmful content such as violence and hate speech in input prompts and outputs. Okay, so we're ready to deploy our model now. So let's open up Azure Foundry, click on Models plus Endpoints on the left navigation bar. Click Deploy Model and Deploy Base Model. You can see the breadth of models being offered. We have a bunch from OpenAI, Meta, Mistral, Cohere, Microsoft, Grok, DeepSeek, you name it. And there are different types of models too. Some are for chat completion, others are for video generation. Today, I'm going to use OpenAI's GPT-4o chat completion model. Feel free to use a different chat completion model if you prefer. I'm going to press Confirm and then Deploy. On the left-hand side, you can see endpoint URI and the API key, which should be kept secret. So don't go sharing it with your friends, colleagues, or cats unless you really want them to have access to your API. You can see that you can choose the language, SDK, and authentication type. For this course, we'll go with the defaults, though probably Entra ID authentication is more preferable in enterprise settings. So let's talk a little bit more about the endpoint. An LLM endpoint functions as an API, much like a black box. If you've worked with APIs before, you know the drill. You send a request and you get a response without ever seeing what's happening under the hood. In the case of the LLM endpoint, your request is the prompt. That is the question that you want to ask the LLM. And then it gives you a response. And that's all we need. We don't need to worry about how the model is exactly working under the hood. In that sense, LLM endpoints aren't a radical new concept. They're just familiar APIs now powered by exceptionally capable AI models. In particular, they are stateless APIs. What's stateless? Well, it's when each request to the API is processed independently, meaning there's no memory of previous interactions. If you want to have a multi-turn conversation, meaning a back and forth dialogue between you and the AI, you will need to explicitly pass previous messages of you and the AI as part of the prompt. These previous messages are called your history. And yes, that's exactly how ChatGPT works. It technically has no memory of your history. We'll talk more about multi-turn conversations in future videos. Now you might be thinking, if I need to pass in my question as well as the history of our conversation to the model, that's a lot of text. Are there any limits? Yes, there is. LLMs operate with token limits. Tokens are the basic units of text, typically short sequences of characters like words, subwords, or punctuation that language models use to process and understand input. A phrase like, "I know an unlovable cat," may be tokenized as follows: I know an unlovable cat. So, a total of 7 tokens. Something like GPT-4o is working with the 128K token limit. That limit includes both the input prompt and output response, by the way. Models also have a model output token limit. For something like GPT-4o, it generates a maximum of 4,096 tokens for the response. So we'll definitely be talking about how to limit our input tokens later on in the course. I also want to emphasize that LLM model responses are based on pre-existing knowledge, that is, the massive datasets they have been trained on. They don't have the capability to browse the internet or fetch company data. And if the LLM hallucinates, meaning it starts making things up or leads you astray, your feedback can help it course correct during that session if history is enabled. But it won't necessarily improve future sessions since you're not retraining the model itself. But don't be disheartened. There are ways we can feed in real-time search results and proprietary data to our input prompts as well as improve our responses. But more about that in future videos. In the next video, I'll be introducing a Python library and we'll be testing out our model endpoint. See you soon!